This video is about resistor networks, what they are, how they can be used as a voltage divider, and also an example showing how it can be used to control the amplification in an op amp. So what we have here is a resistor network. It's a precision resistor network made by Caddic. It has 4 resistors internally in one electrical component. I have the spec sheet up here on the computer, and it's the one on the right. And you can see you have multiple pins that basically connect to resistors internally. These are the resistors internally. They're connected in series. And this is exactly the resistor setup that I have on the breadboard that we were just looking at. So there's a 900 ohm, a 90 ohm, a 9 ohm, and a 1 ohm. So as you go from right to left, for example, across these two taps, you'd get 1 ohm. Across the 5th and the 3rd, you'd get 100 ohms. Then you'd get, 10 ohms. Then you'd get 100 ohms to go from here to here. And then you get 1,000 if you go across the entire thing. Also, you can get ratios of 10 to 1 just by tapping between, say, a 9 and a 90 or a 90 and a 900. So that's kind of a way that you can use that to control, say, the amplification factor in an op amp, which we'll be doing in a minute. What I have here is a power supply that's outputting 1 volt across that resistor network, so that the voltage is coming in here, the ground's over here. And then I'm also tapping off of this with a voltmeter. That's my flute meter. So we can watch as I move this red lead here along the taps to see what the voltage divider does. And it's fairly straightforward. We have 1 volt across the whole thing. I'm close to the ground now, so what we're looking at in the first lead is 1 millivolt of output. As I move to the next one, it's higher. As we move closer to the source voltage and input voltage, that's 10 millivolts. Move to the next one, we get 100 millivolts. And then as I move to the input, we'll get the full input, which is 1 volt. So that's very simple, very direct use of a resistor network to just create a voltage divider. So it simplifies the number of components you need, and you can also control the precision between that division of voltage. The next thing I have here is an example of a inverting op amp, and it's actually running at the moment. The input signal is coming in here. This is on my Digital and Electronics Explorer board. I have a sine wave that's being fed into this op amp. The signal is also being fed into the scope into channel 1, and then the output of the op amp is going into scope channel 2. So yeah, these wire colors will match the output color on the scope. As we look at it here, yeah, the input's in yellow and the output is in blue, and you can see that there's like a 10 to 1 ratio exactly between the scales. So the input signal is peaks at 0.2 volts or 200 millivolts, and then its lower value is minus 200. So it's a 100 milliamp signal basically that is a sine wave, and then it gets amplified by this op amp. The op amp has a variable resistor here, so I can put a screwdriver on that and turn it, and we can change obviously the amplification up to the input voltage or near it. It's got 9 volts plus or minus is the power that's being fed into the op amp, so you can't go much higher than that. That's why it clips at the top there. But in any event, you could, by turning this screw, turning the variable resistor, I can modify the amplification factor just by virtue of the design of the op amp and the ratio of the resistors here and here per this formula for a inverting op amp. You can see the signal is inverted, obviously here between the input and the output. And the last thing to show is if I was to replace these resistors, this and this, with this Cadec precision resistor network, then I can achieve a precise ratio of amplification and not have to worry about making those adjustments to a variable resistor, for example. So there we go. I've hooked that up so that it's going through the 90 and the 900 ohm resistor. So there's a 10-to-1 ratio. You come over here, and indeed you've got the amplification that you would expect. There's a 10-to-1 ratio between these scales, and you're getting the inverted signal. So no adjustment necessary. You get the ratio that you design the system to achieve without having to make any adjustments. All right, that's it for this video. Thanks for watching.